Hello, I'm Dr. Sisser, and this is a series of videotapes on elementary algebra. In all, there will be a total of 10 tapes, and they will provide you a review of the basic ideas of elementary algebra. In this first tape, we will be going over the concept of order of operations and addition, subtraction, multiplication, and division of signed numbers or integers. We will be going over these ideas basically by example. Let's start with the following example, 10 minus 4 times 2. Now, if you had never studied the idea of order of operations, and you were faced with this problem, two people doing the problem might get two different answers. Somebody might say, well, this is equal to 10 minus 8, because 4 times 2 is 8, and 10 minus 8 is 2. On the other hand, somebody else might say, well, isn't 10 minus 4 6? And why can't we multiply the 6 times the 2 and get 12? Okay, well, we don't want to have two different people doing the same problem and getting two different answers. So what we're going to do is specify an order in which arithmetic operations have to be performed. And according to this order of operations that I will give you, this will be the only correct answer. The order of operations will be as follows. First of all, we will handle all grouping symbols. We will simplify the expressions within grouping symbols. When I say grouping symbols, I mean parentheses, brackets, braces. Any expression that's within a grouping symbol will be simplified first. Then we will, as we proceed from left to right, handle all multiplications and divisions. And then finally, we'll go through again, proceeding from left to right, handling the additions and subtractions. And these, remember, we're going from left to right. All right, well, this particular problem over here did not have any grouping symbols, but it certainly had a multiplication indicated by these parentheses and a subtraction. And according to the order in which we perform arithmetic operations, multiplication must precede the subtraction. So going from left to right, the first thing we do is the multiplication. That gives us the 10 minus 8, and then the subtraction to give us the 2. We go through again and get the subtraction the second time. We cannot perform the subtraction to get 6 before we do the multiplication. Okay, now, suppose you really wanted the answer in this problem to be 12. Okay, you wanted the subtraction to precede the multiplication. Well, we could get around that with grouping symbols. If you use grouping symbols, you can change the priority of these various operations. For example, if I wrote down 10 minus 4 in parentheses times 2, 10 minus 4 is now in a grouping symbol, and therefore it has to be handled first. So in this way, we could have the subtraction done first. That would give us 6 times 2, and that would give us 12. But unless I see those parentheses around the 10 minus 4, okay, without them, then the multiplication must precede the subtraction. The parentheses, which are the grouping symbols, which is the grouping symbol in this case, indicates that what's within the grouping symbol should be handled first. Okay, 10 minus 4 is 6. 6 times 2 is 12. But without the grouping symbol, then we just simply go through multiplications and divisions and then additions and subtractions in that order. Okay, let's try another example. 18 minus 8 times 5 minus 3. And the 5 minus 3 is in parentheses. Well, according to order of operations, we first simplify what's in the grouping symbol. So we get 18 minus 8. Now 5 minus 3 is 2. And now, going through, order of operations dictates that the multiplication should precede the subtraction. So we'll have 18 minus 16, performing the multiplication first, and then 18 minus 16 gives us an answer of 2. Of course, if the problem had been 18 minus 8 in parentheses times 5 minus 3, then we would first simplify what's in the grouping symbols. That would give us this subtraction, giving a result of 10, times this difference of 2, and that would give us 20. But without the extra pair of parentheses, this multiplication is performed before the subtraction. All right, let's now review the basic principles of arithmetic on integers. If you would like to add two integers or, extending it further, just any two signed numbers, we have the following rules. Let's look at some examples. If we have, say, plus 6 and a plus 2, minus 6 and a minus 2, plus 6 and a minus 2, and minus 6, and we'll add to that a plus 2. We have 4 addition problems. Addition of integers. These are signed numbers. Now, the rule for addition of integers or signed numbers is the following. When you're adding two signed numbers, mentally, well, we divide it depending whether the signs are the same or not. If the signs are the same, mentally block out the signs, add the numbers as if they were natural numbers. 6 plus 2 is 8, and then prefix the common sign. So we get plus 8. When you're adding integers that have the same sign, block out the sign. Minus 6 and minus 2, they have the same sign. We're adding them. Block out the sign. Add the natural numbers, 6 plus 2 get 8, and prefix with the common sign. Okay? Here's when we're adding them and they have the same sign. If they have different signs, however, the numbers that are being added, we have to follow a different rule. Okay, when the numbers you're adding have different signs, we're going to once again mentally block out the signs, but this time we're going to subtract the smaller natural number from the larger. So 6 take away 2 gives us 4, and then we're going to prefix the sign of the larger natural number. Well, 6 is larger than 2, and its sign was plus, so the answer is plus. Similarly over here, different signs, we want to add them. Block out the signs, subtract the smaller from the larger. 6 take away 2 is 4. Look at the larger of the natural numbers. Its sign was minus, so the answer has a minus sign. Okay, so for addition of signed numbers, the rule is to first, you have to look at the signs. If they're the same sign, you do one thing. If they're different signs, you do another. Same sign, you block out the sign, add the corresponding natural numbers, and prefix the common sign. When they're different signs, block out the signs, subtract the natural numbers, the larger minus the smaller, and prefix with the sign of the larger natural number. Okay? Now, we've written these problems vertically. Sometimes the problems are written horizontally, and you have to get used to it in both ways. For example, this could be written as plus 6 and a plus 2. And then you would write plus 8. Or minus 6 and a minus 2, giving you a minus 8. Okay? So the numbers can be written horizontally or vertically, and of course you do it the same way. Okay, now this was for addition of integers. When it comes to subtraction of integers, we follow a different rule. If we want to subtract two numbers, and I'm saying now for integers because we're working with whole numbers, but later on this will be for any signed numbers. Okay, the rule is very simple. All you do is add the opposite. Instead of a minus b, it's a plus the opposite of b, plus a minus b. In other words, you're going to change the operation from subtraction to addition, and the number that you're subtracting, you will put a minus sign in front of it. And then you will proceed by following the rules for addition of integers or addition of signed numbers. Let's try some examples. Let's say we have a plus 3, take away a plus 5. Well, according to this rule, if you want to subtract, you simply add the opposite. So we will add a minus 5. So instead of plus 3, take away a plus 5. A in this case is plus 3 and B is plus 5. We'll write A plus a minus B. That is plus 3 plus a minus 5. Now over here, we want to add two signed numbers. Well, plus 3 and minus 5 have different signs. So how do we add signed numbers when they're different signs? We block out the sign. We see 5 and 3. 5 take away 3 is 2. The larger of the numbers was 5, and it had a minus sign, so the answer has a minus sign. Minus 3 take away a plus 5 would be minus 3 and a minus 5. We change to addition, and we add the opposite. Minus 3 and a minus 5, now we've reduced this to an addition problem, and the numbers have the same sign. Therefore, we just add the natural numbers 3 and 5, and we prefix with the common sign, which is a minus sign. Plus 3 take away a minus 5 would be plus 3, and then add the opposite of minus 5, which of course is plus 5, giving us plus 3 and a plus 5, which is a plus 8. Of course, 3 plus 5 is 8. We knew that before we started algebra. But here, think of them as signed numbers, same sign. Add the corresponding natural numbers, the 3 and the 5, and prefix with the common sign. Minus 3 take away a minus 5 gives us minus 3, and then add the opposite of minus 5, which is plus 5. Now we're adding signed numbers. They have different signs, so we will subtract. 5 take away 3 is 2. The larger number was the 5. It had a plus sign, so the answer has a plus sign. Okay, now, so far I have been writing every number with a sign. Okay, plus 3, minus 3, and so on. Very often we leave the signs out for the positive numbers. So, for example, if the problem said 3 minus 5, that would be the same as plus 3 take away a plus 5. Similarly, if I had here minus 3 minus 5, okay, if I had minus 3 minus 5, this would tell me minus 3 and then take away a plus 5. Okay? This minus must refer to a minus 3 here. This indicates a subtraction, and the number 5, we've omitted the sign because it was a positive number. Similarly, over here, this must be a plus 3, take away a plus 5. If we don't see a sign, we will assume the sign is positive. Plus 3, take away plus 5, minus 3, take away a plus 5. And in that way, we can cut down on some of the parentheses that we use. Okay, let's try some more of these. minus 8 plus 5. Okay, this must mean minus 8 and a plus 5. We're adding sign numbers. They have different signs, so we subtract. 8 take away 5 is 3. We prefix with the sign of the 8, which is a minus. Minus 8 minus 5. That must mean minus 8 take away a plus 5. Minus 8 take away a plus 5. To subtract, we will add the opposite, so minus 8 and a minus 5. Here we're adding sign numbers. The signs are the same, so we add the 8 and the 5, 13, and we prefix with the common sign, the minus. All right, now let's study multiplication and division of sign numbers. I'm giving the rules, stating them now for integers because we're really not working with fractions yet, but the same rules will apply for any sign numbers. Okay, when you are multiplying or dividing two sign numbers, mentally block out the signs and perform the corresponding multiplication or division. Then go back and look at the signs. If the two signs in the problem were the same, the answer should be plus, whatever you found. And if the two signs are different, the answer should be negative. Let's look at some examples. For example, if I have minus 6 times plus 2. Block out the signs, perform the corresponding multiplication, and get 12. And prefix with the correct sign. If the signs are different, the answer is minus. If the signs are the same, the answer is plus. Well, the signs are different, so the answer is minus. Minus 6 times minus 2. Once again, block out the sign. 6 times 2 is 12. They're the same, the signs, and therefore the answer is positive. Plus 6 times minus 2. 6 times 2 is 12. The signs are different, so the answer is minus 12. And of course, plus 6 times plus 2, which is just 6 times 2, should be 12, and the answer, of course, should be positive. Because 6 times 2 equals 12 was true before you started studying algebra. Okay, for division, the same kind of idea. If I have minus 6 divided by a plus 2. Block out the signs and perform the division. 6 divided by 2 is 3. Then look at the signs. A minus and a plus. Different signs means a negative answer. Minus 6 divided by minus 2. Perform the division. 6 over 2 is 3. Same sign, therefore a positive answer. Plus 6 over minus 2. 6 over 2 is 3. Different signs, a negative answer. And of course, plus 6 over plus 2. 6 over 2 is 3. Same sign, so it's a positive answer. Okay. Now I just want to review the idea of absolute value of a number, and then we're going to be doing many examples using all these ideas. The absolute value of a number is basically the distance of the number from 0 on the number line. So if we have our number line here, here is 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, and so on. If I say the absolute value of 3, that's the distance between 3 and 0 on the number line. That's 1, 2, 3 units, or 3. If I say the absolute value of minus 2, I'm talking about the distance between minus 2 and 0, and that's 2 units. So the answer is 2. Basically, if a number is positive, or 0, the absolute value of the number is just the number itself. If the number is negative, however, to get the absolute value, we have to put a minus in front of the number. Okay? So, for example, if I say the absolute value of 4, 4 is positive, and therefore, to get the absolute value, we leave it alone. The absolute value of minus 5, this is a negative number. To get the absolute value, we put a minus sign in front of the number. That is, we take the opposite of the minus 5, and that comes out to be plus 5. So for positive numbers or 0, the absolute value is the same as the number that we started with. For negative numbers, we will put a minus sign in front of the number to achieve the effect of giving us the distance of the number from 0. Okay, let's try some examples. The absolute value of 3 minus 7. Well, this is the absolute value of, this must be a plus 3 take away a plus 7 within the absolute value. Okay, now to subtract, what we do is we add the opposite, so it'll be a plus 3, and instead of taking away a plus 7, we add a minus 7. Now to add two signed numbers, we do this within the absolute value. First, we're working from the inside out. To add two signed numbers, they have different signs. All right? So we forget the signs, we subtract. 7 take away 3 gives us 4. Okay? The larger number was the 7. It has a minus sign, and therefore the answer has a minus sign. Now we need the absolute value of minus 4. But minus 4 is a negative number, and to get the absolute value of a negative number, we put a minus in front of the number to get a final answer of plus 4 or 4. All right, let's try this. Minus 2 plus the absolute value of minus 5. This must mean minus 2 plus, now the absolute value of minus 5. Well, the absolute value of minus 5, it's a negative number, so we put a minus in front, and we get plus 5. The absolute value of minus 5 is negative minus 5 or plus 5. Okay, so the absolute value of minus 5 is plus 5. And now we add a minus 2 and a plus 5. Okay, to add signed numbers that have different signs, we block out the signs, we subtract. 5 take away 2 is 3, and the larger number was the 5. It had a plus sign, so the final answer is plus 3. Notice the difference between this example and the preceding one. In the preceding one, all the work was first done, and then you took the absolute value at the end. Okay? First you did the subtraction, and then after the end, when you get the final answer, you take the absolute value of that. Here, however, the absolute value was just part of the problem. We had to take the absolute value of minus 5 early on, and then add it to the minus 2. Okay? Minus 2 take away the absolute value of minus 5. That must be minus 2 take away. Now the absolute value of minus 5 is, as we saw before, plus 5. Minus 2 take away a plus 5. When you subtract, you add the opposite. So we have a minus 2 and a minus 5. To add signed numbers with the same sign, we add the numbers without the sign. 2 plus 5 get a 7, and prefix with the common sign. Now what about this? Minus 2, and then the absolute value of minus 5 written just like that. Okay, now I didn't leave anything out. When you see this, minus 2, and the absolute value of minus 5 written without a plus or a minus, this must mean multiplication. It's minus 2 times the absolute value of minus 5. So that's minus 2 times the absolute value of minus 5, which we already know is plus 5. And now this multiplication of sign numbers is done by ignoring the signs and saying 2 times 5 is 10, and then saying, well, the signs were different, and therefore the answer is negative. So negative 10. Okay, let's try another example. Suppose we're multiplying and we have more than 2 numbers to multiply. Minus 5 times minus 3 times minus 2. What do we do in this case? Well, we can group them in some way. For example, we could take the first 2 numbers, multiply them together, and take that product and multiply it by minus 2. Well, minus 5 times minus 3 is plus 15. Okay, the numbers 5 times 3 multiplied to 15, and of course the 2 numbers have the same sign, so the answer is positive. So this is plus 15, and we still have the minus 2. Plus 15 times minus 2 gives us 30 prefixed with a minus sign. Minus 30. All right. What about this? Minus 3 times plus 4 times plus 2 divided by minus 6. Once again, we can do a little bit at a time. The minus 3 times the plus 4 gives us a minus 12 times the plus 2 over the minus 6. And then the minus 12 times the plus 2 gives us a minus 24. And dividing it by the minus 6, well, 24 over 6 is 4. They have the same sign, so the answer is plus 4. Another example. 5 minus 6, and then in brackets, 2 minus 4. Okay, now we're going to be using order of operations in conjunction with our work with sign numbers. Well, the first thing we have to do is simplify what's in the grouping symbol. 5 minus 6. Now remember that 2 minus 4 really means plus 2, take away a plus 4. Of course, after a while, you won't need these intermediate steps. And if you want to subtract sign numbers, we add the opposite. So instead of a minus b, we have a plus a minus b. And still in the grouping symbol, we now add sign numbers, and they have different signs. So it's 4 take away 2 gives us a 2. And since the 4 was the larger of the numbers, the minus sign must precede the answer. Now, we have simplified the expression in the grouping symbol. So all we have to do here is perform the multiplication before the subtraction. 5 take away. Now, 6 times minus 2 will give us a minus 12. And instead of subtracting, we will add the opposite to get a final answer of plus 5 and plus 12, or plus 17. I want to point out that we sort of have a choice here. What I did was to say it's 5 take away, and then I did this multiplication, which gave us a minus 12. Okay? But of course, when you came time to subtract, 5 take away a minus 12, you had to add the opposite. Another choice is to say this is 5 plus the product of minus 6 and minus 2. That is 5 plus the plus 12. So you can go from here directly to this step if you want to. Either think of it as 5 take away this product, or 5 plus the product of minus 6 and minus 2. All right, suppose the problem had said 5 minus 6 times 2 minus 4. In other words, there were parentheses not only around the 2 minus 4, but there was also a grouping symbol around the 5 minus 6. Now this would have the effect of forcing you to simplify within both grouping symbols before you did the multiplication. Now we've already seen that 2 take away 4 gives us a minus 2. Similarly, plus 5 take away a plus 6 is the same as plus 5 and the minus 6, which will give us a minus 1. And a minus 1 times a minus 2 is a plus 2. Okay, so notice how I can have the same integers involved in a problem and get two different answers. So it's very important to pay attention to the order of operations. Remember, first we handle whatever's in the grouping symbol has to be simplified. Then we go through doing our multiplications and divisions, and then finally our subtractions and additions. In this problem here, we had to do the subtraction because it was in the grouping symbol, but then we did the multiplication, and then finally the last subtraction. Okay, let's try another problem. Minus 9, take away, in brackets, 3, take away, 8, in parentheses, 6 minus 4. Close parentheses, close brackets. Okay, we can have more than one level of grouping symbol, in which case we work with the innermost first. So I'm just going to rewrite the rest of the problem the way it was and just try to simplify what's in the innermost grouping symbol. Well, 6 take away 4, of course, is 2. Plus 6 take away a plus 4. Now, still within now the larger grouping symbol, we have to handle what we have here. Now within the grouping symbol, order of operations holds, and the multiplication has to precede the subtraction. So we get 3 minus 16 in there. Take away now. 3 minus 16 plus 3, take away plus 16 is plus 3 and the minus 16, so we subtract. 16 take away 3 is 13, and we prefix with the minus sign. And now, minus 9, instead of subtracting, we will add the opposite. So that's minus 9 and a plus 13 to add. We're adding numbers, different signs, so it's going to be 13 take away 9 is 4. The larger number was the 13. It had a plus sign, so the answer comes out to be plus 4. Okay, let's try the following. If you see 6 minus 7 plus 3 minus 8 in a row like that and you want to handle it, remember that positive numbers, we very often leave a sign out. So what we really are talking about here is a plus 6, take away a plus 7, adding a plus 3, and taking away a plus 8. Well, plus 6 take away a plus 7 means plus 6, and instead of subtract, add the opposite, plus 6 and a minus 7, and then plus 3, and instead of subtracting a plus 8, we will add a minus 8. Looking at it at this point makes us realize there's really another way of interpreting the problem. Now, what I had said before is that every time we see a number without a sign, we can think of it as a plus, which is true. Another way of looking at this, however, is that what we see here are really the signs of the numbers, and it's all addition. In other words, it's a plus 6 and a minus 7 and a plus 3 and a minus 8. And we see that the second line indicates that this is really equivalent to the original problem. A plus 6 and a minus 7 and a plus 3 and a minus 8. So whichever way you happen to look at the problem, okay, thinking of them as the positive numbers are missing the sign this way, or just addition of these numbers and these are their signs, you get the same answer. Now, when you are faced with adding a group of signed numbers, the best thing to do, I would think, is to sort of group the positives and the negatives separately. In other words, let's handle this and this. The +6 and the +3, of course, gives us a +9. The -7 and the -8 gives us a -15. And that leaves us with, in other words, we take all the pluses together, handle that, add them up and prefix with the common sign, all the minuses together, prefix with the common sign, and that leaves us with a positive and a negative to add. We do that by subtraction. 15 take away 9 is 6. The larger number was the 15, and it had a minus sign, so the answer is -6. Okay, let's try some more problems. If I have 5, take away 9, take away 2, this means one way of looking at it is a +5 and a -9 and a -2. Or if you prefer the other way of looking at it, it gets to the same point. In other words, if you prefer it this way, you could think of it as a +5, take away a +9, take away a +2. Either approach is acceptable. Whereas this is a +5, take away a +9, take away a +2. Of course, if you do write this step, the next step is to change the subtraction to addition and add the opposite. Change the subtraction to addition and add the opposite. So it's perfectly okay to think of it as a +5 and a -9 and a -2. That's a +5, and, well, -9 and -2 gives us a -11. +5 and a -11 gives us a -6 for our answer. Now, what if it had been 5, take away, in parentheses, 9 - 2? Now we handle what's in the grouping symbol first, so it's 5, take away. Now 9 - 2 is 7. So we have a +5, take away a +7, or a +5 and a -7 for an answer of -2. Now what if it had been 5 times 9 - 2 in parentheses? You see, you have to be very careful. We're talking the same numbers in each case. But the plus and minus signs are a sort of punctuation, and we have to see how they occur. Here, they were just all additions. Here, it's 5, take away this difference. And here, since there was nothing between the 5 and the 9 - 2, it must mean multiplication. 5 times 9 - 2, which is 7, plus 5 times plus 7 for an answer of plus 35. Okay, still using the same numbers. What if I gave you 5, take away the absolute value of 2 - 9? 5, take away the absolute value. Well, 2 - 9, a +2, take away a +9 is a +2 and a -9 gives you a -7. 5 take away. Now, the absolute value of -7 is +7. So we have a +5 take away a +7, which is a +5, and the -7, and that gives us an answer of -2. It's a +5 and a -7, giving us an answer of -2. For our last problem, let's try the following. 9, take away 3, bracket, 4 plus 2, open parentheses, 1 minus 6, close parentheses, close bracket. All right, that gives us 9 minus 3. We're going to handle the grouping symbols from the innermost out. So first time around, I'm only going to worry about the 1 minus 6. Well, 1 minus 6 plus 1 take away a plus 6, or a plus 1 and a minus 6 gives us a minus 5. Okay, now we're going to worry about what's in the larger grouping symbol. Once again, we have to use order of operations even in the grouping symbol. 4 plus, now 2 times minus 5 is a minus 10. Still simplifying in this larger grouping symbol, a plus 4 and a minus 10, adding sign numbers, gives us 10 take away 4 is 6 with a minus sign in front. And then we have 9, and either think of it as minus 3 times minus 6 and add it to the 9, or if you prefer 3, okay, take away now, 3 times minus 6 is minus 18. Of course, that still gives you that you have to add the opposite. So whether you take a direct route or you stop off on that step, certainly you can get the same answer. Think of this as plus minus 3 times minus 6, so plus 9 and a plus 18 for a final answer of plus 27. And that brings us to the end of this videotape.